Okay, we're keeping on with functions. 2.4, this is Monday night, and you will finish the worksheet Tuesday in class. So we're talking about functions still, and we have this thing called function notation. Function notation looks like this. We say it's the exact same thing as y, and we say f, and then we say of x. So that's how you say it. You say f of x. And if it happened to be, it could be this too, we would say g of x. So basically that's showing the relationship, that there is a relationship between x and y. If you say f of x, then we know that it's a function that has to do with x. If you say y, it could or couldn't have anything to do with x. So when you do f of x, it's just a different way to say y, but it kind of wraps together your y in there and makes it a little easier to do some of the things we're doing, like at the bottom of the page and in Algebra 2 and all that good stuff. Okay, so that's that. Domain is x. We already did this, right? It is the horizontal line. It is the independent variable. And it goes from left to right. The range is your y, or now you know it could be f of x. It's vertical. It's dependent. And it goes from bottom to top. That's always how you list the values. Okay, I have no idea what we were supposed to do in this box right here. So we're just going to skip it, because I'm not sure what other information you need to know about that. So we're just going to skip that part. Okay, to find f of x, you simply substitute, and I don't think I can make it fit in here with my big old handwriting. That's close. To find f of x, you simply substitute the value of x into the equation everywhere you see an x, which makes total sense. So if you're evaluating f of x equals 4x minus 3, and the domain, which one is domain, x or y? Domain is x. So we're putting this in, -1, 0, and 2, in for x 3 different times, and we're going to get 3 different answers. So if you have 3 domains, you're going to have 3 ranges, because those would basically be your ordered pairs. So let's take -1, and I'm going to write f at -1 equals 4 times -1 minus 3. So that is equal to -4 minus 3, which is equal to -7. Okay, I'm going to put in f at 0, which is going to be 4 times 0 minus 3, and that's 0 minus 3, so that's equal to -3. And then I'm going to do this one more time with the 2. F at 2 is equal to 4 times 2 minus 3. So that is equal to 8 minus 3, which is 5. So if they give you the domain as 3 numbers inside the brackets, then our answer is going to be 3 numbers also inside the brackets. So your answer would be -7, -3, 5. If we wanted to know what the ordered pairs were, we basically have -1, -7. Then the next one is going to be 0, -3. And then the next one would be 2, 5. So the domain they gave us was -1, 0, and 2. And the range, which we just found, was -7, -3, and 5. So just notice that this is the same thing as these guys, just broken up into 2 different lists for the domain and range. Okay. Number 2. Now we're going to look at this graph and we're going to find the values of f of x, but we're just going to look on the graph. So if we're looking for the value of f at 8, or f of 8, okay, the 8, because it's inside the parentheses, is your x value. So we're looking for, when x equals 8, what is y? So if x equals 8, I'm going to come over to the graph, and here is f equals 8. So when x equals 8, f of 8 equals 0, because the ordered pair for this is 8, 0. So if x is 8, f of 8 is 0. We're going to find the value of f of 16. So 16 is x, because it's inside the parentheses. And f of 16, I'm going to go look at my graph. I'm going to find x equals 16. I'm going to follow my line up to f of 16 is 12. So the order pair would be 16, 12, and that would fall on my line. Okay, so C, now we're changing it around. Because we have f of x equals 4, that's y equals 4. Same thing, f of x, so really this is f of x right here. F of x and y are the same. So if I go to y equals 4, and I go across for x, notice that I have one value right here and one value right here. So when you have y values, when you have x values, there could be more than one for the same y value. So x is equal to 4, and x is also equal to 12. Because 4, 4 is an ordered pair, and 12, 4 is also an ordered pair. So you could write your x's like this, or you can write them like this. I don't care. I'll know what you mean. So any of the above ways is fine. Okay, so here we have another f of x. So we're looking for y equals 16. We're going to go up and find y equals 16. We're going to go across. And again, I have two values where y equals 16. So x is equal to, I'm going to go down 18. And x is also equal to 24. So those are my two x values. Okay, now we're going to get a little trickier. So we're looking for x values if f of x is greater than or equal to 10. So that's our y greater than or equal to 10. So if I wanted to do that on my graph, I would find y equals 10. And I'm going to draw a solid line because we're including those values. And I'm doing greater than, so basically I'm looking at all this up here as y is greater than 10 or equal to. So where are my x values when I have y is greater than or equal to 10? I start right here and I end right here. So this value of x right here looks like it's in between 14 and 16. So I'm going to say this one is 15. And that's included because we have a solid line at y equals 10. And this one is x equals 26. Okay, so it's in between 15 and 26. So I'm going to write 15 less than or equal to x less than or equal to 26. So for this range, this would be my domain. Is this graph a function? Well, we have a couple ways to look at it. We can see a vertical line test. Is there any place where that line, I'm talking faster than I'm working. Is there a vertical line you could draw that would pass through, the relation would pass through 2 points? And the answer is no. You could also look at your x values and say, oh, they never repeat. They just gradually go up higher and higher. So it is a function I would say vertical line test. You can say no repeating x's, whichever one is fine. Okay, so let's write the domain and range of the graph. So my domain is going to be, it's getting awful messy up here, right here, which is 0, which is also going to be my range because it goes down to 0, and 26, which is my greatest value for x, and then my highest value for y is up here at 20. So my x is going to be 0 less than or equal to x, because that dot was solid, less than or equal to 26. And the range is going to be 0 less than or equal to y less than or equal to 20. So don't forget, it's not where your line ends that tells you your domain and range. It's where it's the highest point and the farthest to the left and right points. Okay, so now we're just going to solve some functions by substituting in values for x. So if we're doing f of x equals x minus 9, then f at 3 is going to be 3 minus 9, which is equal to -6. And that's all we're doing, and that's your answer. Now, if I want f at 4x instead of f at x, basically I'm taking my x value and I'm substituting in 4x. So I have 2 times 4x minus 1, and that's going to give me 8x minus 1. And I can't combine any more terms, so that's my answer. Okay, last one. Now we're going to do two things. We're going to substitute this in for x, and then we're going to add 5 to the end. So here's my x squared. It's going to be -2 squared minus 3 times -2 plus 2, and then I'm going to stick plus 5 on the end. So -2 squared is 4, minus 3, -3 times a -2 is plus 6, plus 2, plus 5. So I end up with 6 plus 4 is 10, 2 more is 12, and 5 more is 17. So there's my answer. So they're making them a little complicated and adding on some extra things like this plus 5, but all that does is just means one more thing you add on. So now we're getting into more brackets. So we know what f of x is. We want to solve f of x for f at 3, and then this 2 right here is going to be multiplied at the end. So I'm going to have 2 times 5 times 3 minus 3. Okay, I put in 3 in for my x, 5 times 3, and then my 2 at the very end, because it's in the front, at the very end I'm going to multiply times 2. So I have 2 times 15 minus 3. And you can do brackets or parentheses. And then you have 2 times 12, which is equal to 24. So that's your answer. So just like when we do parentheses and brackets in our order of operation, when you're just solving long strings of numbers, it's kind of the same thing. The brackets are just another way to separate the operations so you can do whichever one first. Okay, so here's another one of those. So we're going to do 3 times when we're finished putting 2 in for x. So we're going to have 3 times 2 plus 2. Everything inside the parentheses first. 3 times 6 plus 2. 3 times 8. And so that's 24. That's all we're doing. Okay, number 8, we're multiplying times 4 after we substitute in -1 and find the answer for f of x. Then we multiply times 4. So we're going to have 4 times 3 times -1 plus 2. 4 times minus 3 plus 2. 4 times negative 1 equals negative 4. That's all we're doing. Okay. Number 9 is really easy because it's just gone. Wait a minute, let's find that again. Okay. Because, first of all, you know that I'm still having a problem here. I keep putting my finger in the way. Something. Okay. You know perimeter. And if it's a rhombus, all the sides are the same length. And so f of x equals 4s. S is the length of the side. We want to find the perimeter of a rhombus with that. So we're going to use our function notation still. So if f of s equals 4s, and our side is 83, then I want f at 83, or f of 83, equals 4 times 83, which equals 332. So that's our answer. So we just did the same thing you've always done with finding perimeter, multiplying the side times 4. We just used our function notation to show the math steps we did instead of using just quicker substitution. Okay, so number 10, here we have a sequence and we have a pattern rule, and we want to find the 5th term. So that means x equals 5. I don't have to make a table and fill out for all different x's because I only want x equals 5, which is the 5th term. So I'm going to solve for f of 5 equals 3 times 5 minus 1, which is equal to 15 minus 1 equals 14. So that's all we're doing is substituting and solving. We're just using the function notation, which is a little bit new, but doesn't really change anything we're writing. Okay, when they say range, what are we talking about, x or y? Exactly, y. So we want the y to be equal to negative 7, which is the same as f of x. So we're going to put this negative 7 in here. So I have negative 7 equals negative 2x minus 5. I wish I had more room, but I'll just write over everything else. That's okay. Okay, so the first thing I'm going to do is switch everything around because this is going to drive me crazy. Okay, so I'm going to do minus 2x minus 5 equals negative 7. So I'm going to add 5 to both sides. Negative 2x equals negative 2. Divide both sides by negative 2. X equals 1. So if it says the range equals negative 7 or f of x equals negative 7, then you have your y value, not your x value. And we're not substituting negative 7 in where the x is. We're solving for x with negative 7 in for the f of x or y. Okay, and if you have multiple functions, it's just as easy. We're going to solve f of x with 4 and g of x with 4 and add together those two answers. So I'm going to have 2 times x, 2 times 4, which is f at 4, plus g of 4 is 4 squared plus 1. So I end up with 8 plus 16 plus 1, which is equal to, I think, 25? 25. So it's just the same stuff we've been doing. Shouldn't be a problem. So now I'm solving for g at 3 and f at 4. So g at 3 is going to be 3 squared plus 1. And then we're going to add to that f at 4, which is 2 times 4. Okay, so 3 squared is 9, plus 1, plus 8 is 18. And that is that. And hopefully, even though you have all this function notation, you'll see that all we're doing is substituting in. It's just a different way for telling us what number goes in for x so that we can substitute it in and solve. Nothing really new here, except just some more math language that you're going to use. So do well in class tomorrow, and I will see you. Adios.